All right, well, welcome to 60 Minutes in Space for May. I'm going to be doing it alone tonight. I'm Steve Lee, the curator of planetary sciences here at the museum. And boy, I'm not sure what that's all about. So as we always ask, how many of you are here for the first time tonight? Wow, quite a few of you. Okay, just the sort of rules of the road. Since I'm the only guy tonight, I don't have to tell you what the other guys will be doing, but typically we'll have a couple of the other curators, or at least one, that do deep space stories, astrophysics, astronomy, things like that. And then I do solar system, human exploration. Tonight you're going to get all solar system and human exploration, so you'll have to come back if you want to hear about things farther away. And we'll have plenty of time afterwards for questions, so please feel free to ask those, or if there's something that's burning when the slide is actually up, go ahead and shout out the question. I probably won't be able to see you raise your hand, so just go ahead and do it. Just a couple of administrative things to start with, but in case I forget, next Tuesday is the transit of Venus across the sun. And I don't have a slide about that, but that's the, I think the last one was in 2004-ish. The next one will be in 2117. So if you'd like to see it, next week is your chance. And we will be doing an event here at the museum. It will be, I think the transit starts at about 4 p.m. or so our time. If you're in Space Odyssey at that point, you'll be able to get the beginning phases of it, but then we'll have a regular adult program, which, Julia, you'll have to remind me, it starts at 5:30, is that correct? Okay, so check the website, and it is a ticketed event, so please join us for that. We'll have solar telescopes set up so you can see the dot of Venus moving across the sun. We'll have projection systems set up. We'll have video streams in Space Odyssey, and we'll have sunglasses so you can look at it with your own eyes, although it's a little unclear. It's right at the ragged edge with naked eye that you're probably going to be able to see it. If you have particularly good eyes, you might. If you're like me, you probably won't. But anyway, it'll be a great way to safely see this event. And then next month for 60 Minutes, which is on the 27th, I think, of June, we're going to have a special guest. It's Dr. Don Hassler from the Southwest Research Institute in Boulder, and he's the principal investigator on the radiation experiment on board the Mars Science Lab, Curiosity. And he'll be joining us to tell us about that experiment. And that's actually the only instrument that has been on since shortly after launch. So it's collecting information on the radiation environment in interplanetary space, as well as once the spacecraft is landed. And this is, of course, preparing for when we have people on these spacecraft to determine what kind of measures we need to do to protect them. So you can look forward to that at the next 60 Minutes. So, without further ado, I guess I'd like to jump into my usual checklist here. And what I always like to do is go through what has been happening with Opportunity. And Kim, when you have a chance, if we can turn the light down here. So today is day 2968 of Opportunity's 90-day mission. And it's still going strong. And in fact, well, let's do a little bit of the history here. This is where Opportunity has been sitting, right on the edge of Endeavour crater. This is about a 20-kilometer diameter crater. And let's see, here's where Opportunity landed. And then it spent quite a bit of time in Victoria crater, and it spent the better part of 3 years driving to Endeavour. And then when it got right near the rim of Endeavour, the winter hit in the southern hemisphere of Mars. And so what they ended up doing was finding this ridge and they parked it on a north-facing slope so the solar panels would be facing the sun. And this is just a diagram that I've shown a few times before, but this is sort of a self-portrait of Opportunity. This was 300 days or so after landing back in 2004. And this is looking down on the top of the rover, and you can see the solar panels are all very clean, and it's giving lots of energy from the sun. This picture was taken late December of last year, just before it parked, and you can see how dusty the solar panels had gotten. And in fact, it was only putting out about 25% or so of the power that it would have if they were completely clean. And so to help it survive the winter time, they park on a north-facing slope. That improves the output of the solar panels. But basically what they did was stayed in place since the last week in December, and they took some pictures. They analyzed the rocks that were within reach of the robot arm. But I'm happy to say, early this month, I think it was May 8th, they've started driving again. They have enough power now. The sun is, it's early spring in the southern hemisphere of Mars. The sun is higher in the sky, and that improves their power situation. They've also had a few dust cleaning events where the wind gusted just enough that it removed some of the dust. And so they're better than they were when they hunkered down for the winter, and they're expecting things will continue to improve as the sun gets higher in the sky. So here's where they were parked for this time. It was on a small ridge called Greeley Haven. It's named after Ron Greeley, who was a very prominent planetary geologist. He passed away last fall. He was heavily involved in the rover missions, and so that was to honor him. But this was an image released on the 8th anniversary of when Opportunity landed, which was January 24th of 2004. And this was another nice picture taken in March, just very low sun. This is false color, but you see all the inside of the crater is sandier material, and that tends to be bluer. And here we are on the rim of the crater on the ridge of Greeley Haven, and sort of a self-portrait again of the rover's shadow being cast across the surface. And so once they started driving on May 8th, in their reconnoitering over the winter, they noticed that there was a patch that looked like it was a thick deposit of dust within about 5 meters or so of where it had been parked. And they really haven't had many exposures like this where the dust seems to be thick enough that you could actually use some of the instruments to determine the composition of just the dust instead of dust plus rock plus soil. And so they moved over to this area and spent 10 days or so analyzing the dust, and I haven't heard the results of that yet, but we think we know what the dust is made out of, but it's always good to get confirmation. And this is one of the most recent images that have come back. It's been driving now again for the last 3 or 4 days. They've traversed about another 20 meters or so. And this is the ridge that they'd been parked on. So that's Greeley Haven off in the distance, and they're now driving northward along the rim. And what they're hoping to find, they discovered this little outcrop. Each of these bright exposures here, they're about as thick as your little finger. And they found this on their way to their parking place, and it turns out when they analyzed it, this is gypsum, which is a calcium sulfate mineral, but it's a very good indication that water flowed through a crack in the surface and this precipitated out of the water. And what's really exciting is the water is not real acidic or not real alkaline. It's a fairly neutral pH. And so what they're going to do is continue driving along where they found this exposure of gypsum to see if they can find more of it. and analyze that, because that is one of the most significant water-related findings that they've had in the last several years. And it sort of sets the tone for what the environment likely was in this area in the past. So here's the recap. Now, I'd already said it's day 2968. They've driven about 34.38 kilometers and returned almost 170,000 images. And the mission is now ramping back up after its winter snooze. So I'll keep you updated on this in the future. We expect that they're going to drive along the rim, and at some point they're going to get to an exposure of clay minerals that they've detected from orbit. And clay is a very exciting mineral as well, because that's the type of rocks you get when you've exposed the rocks to liquid water and you've sort of decomposed the rocks. You get these hydrated minerals where water is actually bound up in the mineral, and it sort of decays into much finer grained stuff. And so that's what they'll be looking at in the not too distant future. Okay, so the next mission, which is on its way to Mars, is the Mars Science Laboratory, the Curiosity rover. And this launched last November, a couple days after Thanksgiving. It's scheduled to land on August 5th. So we're 67 days and about 4 hours and 15 minutes from landing. It's narrowing the distance fast. And here's where the spacecraft was as of yesterday evening. So the green path is the spacecraft, the orange is Mars, blue is the Earth's orbit. So it took off here back around Thanksgiving. It's been in this looping orbit. It's gone about 440 million kilometers so far, and it's currently traveling just shy of 81,000 kilometers per hour. So it's closing fast on Mars. This is, if the spacecraft had a telescope on it, this is what the Earth would look like. And yesterday we were about 157 million kilometers from the Earth. And looking out the other window, here's Mars approaching, and it's about 22 million kilometers from Mars, so approaching rapidly. The next major event in the mission is going to be a trajectory correction maneuver on June 7th. They're tweaking the path just slightly to narrow in on their desired landing point. So that'll be the third maneuver, and then starting about a week before landing, they have 3 more opportunities to change the path slightly, and so they'll keep zeroing in as they get farther along and they get more information about where they're actually targeted. And so what they've been doing in the last several months is what are called operations readiness tests. And this is where the entire science team goes to the Jet Propulsion Lab in California, and they run through exercises as if the spacecraft is landing, as if it just landed and now we're operating the spacecraft. It's sort of a mission simulation where, just like you're familiar with probably for space shuttle flights, the crew trains very hard in a simulator. Periodically, the people running the simulation throw problems into the mix and see how people react and train them so that you don't have to figure it out for the first time when you're actually on the surface of Mars. And so this is a test rover, or a sort of a Curiosity clone that they can drive around using the real spacecraft controlling software. And so they've taken it, I think this was on May 8th, 3 weeks ago or so. They took it out into the Mojave Desert and ended up spending multiple days driving around and examining the geology of that area. And so I wanted to tell you a little bit about some of these models that we've obtained in the last couple of weeks. And this is sort of a cute factoid that you'll be able to amaze your friends with because they probably won't know about it. This is an image from Opportunity. These are tire tracks. And you notice every so often there's a disturbed spot here. And what that is, on Opportunity and Spirit, they had bolts holding the wheels to the lander. And so there were holes in the wheels, but they served a double purpose. Once the rover was out roving, then these act as a visual odometer. Every time the wheel rotates, it leaves an imprint on the surface, and they don't really have an odometer on board. So just by taking a picture, you can say, well, there's 1, 2, 3, 4, 5, however many of these spots, and you know what the circumference of the wheel is, so you can tell with fairly great accuracy how far you've traveled. And Kim, if you could bring the lights up. I guess I'll put my remote control down here for a minute. So this is a full-scale model of one of Curiosity's wheels. And we're soon going to have this out in the display case where the rover model is in the atrium, and you can compare this to Spirit and Opportunity. It's probably 4 times the diameter. And I'll have this in the back of the room at the end of the evening so you can look at it closer. But if you see these spokes in it, these are titanium. The wheel itself is carved out of a solid block of aluminum. And the spokes act as a suspension system. So the way that the rover lands, it uses these not only as wheels to drive across the surface, but it's the landing gear. So it drops under this sky crane spacecraft, bounces down onto all 6 wheels, and so the spokes actually provide sort of a springiness to that. But what I wanted to show you here, if I can find them, and I'm not sure how well you're going to be able to see this from in the back, but you notice there's 3 rows of holes in the wheels. And so those are going to serve as the visual odometers, the same as they did on the other rovers. But sort of a well-kept secret is the spacecraft was built at the Jet Propulsion Lab, a NASA facility in Pasadena, California. And originally they had a big JPL logo on top of the rover. So in many of the pictures, you'd get a JPL logo. And apparently NASA headquarters decided that was not a desirable thing to do and forced them to take the logo off. So what they did instead is spelled out in Morse code, JPL. And so every wheel revolution, all 6 wheels, it'll be leaving JPL, JPL, JPL across the surface of Mars. And so you can amaze your friends with that fact when it's actually landed, and you'll see these dot patterns left in the tire tracks. Okay, so that's just another example. This was the image I showed earlier of Greeley Haven, and you can see, you could take an image, and if you blow this up, you could count back many tens of meters and do some pretty accurate estimation of how far you've traveled. So I think the next slide is what's called the MSL trailer. They've put together sort of a movie trailer version of what's going to happen on landing night, and it's very quick and sort of zippy. So, sorry, I was wrong. First, before we get there, this is the landing site, and this is called Gale Crater. It's about 100-kilometer diameter crater, and this ellipse is where they're targeting Curiosity to land. What's driving them to this location is this mountain in the middle of Gale Crater. It's a mound of layered sedimentary rocks. It's about 5.5 kilometers high, so 18,000 feet or so. And they can tell with spectrometers from orbit that near the base of the mound on this side, there are lots of clay minerals. And so that's very enticing. There looks to be a riverbed going into the crater, and so in all likelihood this was a crater lake at some point in the past. And what they're hoping to do is, let's see, I think I have just a comparison here. So they've named this Mount Sharp after another planetary geologist. So that's how tall it is, this tan area. In comparison, here's Mount Rainier, Mount McKinley, and Mount Everest. So it's nowhere near Everest height, but it's getting up there to, taller than Mount Rainier, about as tall as Mount McKinley. And what they're hoping to do is drive up the side of this mountain over the course of several years. So the first thing is to explore all the clays at the bottom, and then they'll drive up or near one of these canyons cutting into the side of the mountain. And if the geology works the same way as it does on Earth, and we expect it does, as you get higher up the mountain, the rocks are going to get younger. And so that'll give you a history of the climate and the environment that was in place when the different layers of rocks were laid down. And that lets you have a chronology of what was happening in this location of Mars in the past. So I think now we'll get on to the trailer. So here we were last 2 days after Thanksgiving, launching from Earth. And so this is the cruise stage that's carrying Curiosity. And here we are on August 5th now. It slams into the atmosphere at about 20,000 kilometers an hour, has a heat shield to protect it and slow it down. At about Mach 2, it pops a parachute, slows it down even further, drops the heat shield, and then it drops what's called the sky crane, which is essentially a rocket-powered helicopter. And then it lowers Curiosity on these 60-foot tethers. As soon as the wheels touch ground, the tethers are cut and the sky crane flies off into the distance and crashes. And at that point, Curiosity is ready to do its business. So, there we are. So just to remind you, we are doing a landing event here at the museum. It's August 5th, which is a Sunday. The landing itself is at about 11:30 p.m. Mountain Time. And we'll be starting at about 9 p.m. We'll have representatives from United Launch Alliance that built the rocket that launched the spacecraft. Lockheed Martin built the heat shield and the aeroshell, the capsule that gets it to Mars. We'll have a couple of scientists that have been involved in the Spirit and Opportunity missions that will be able to tell you what it's like once these things land, how intense it is for the first couple months when you're actually living with a Mars clock, which every day your day is shifting by 37 minutes compared to the Earth. And you have to live on spacecraft time. And so we'll have the live NASA TV coverage. We'll have all these people. We'll have various demonstrations. We'll have refreshments. And then we'll hang in until 2 or 2:30 in the morning when the first images are likely to be coming back from Curiosity. So I think the website is already taking reservations for this. So I'd encourage you to get reservations. The way this is going to work is we'll have one audience in IMAX, about 400 people. We'll have another 225 or so in the Ricketson Auditorium. We'll have people here. We'll have people in the West Atrium. I'm sorry, in the Northeast Atrium. And we'll have people in Space Odyssey. But the live presentations will be in both IMAX and Ricketson, and so it's sort of first come, first serve. You'll be assigned to those venues based on when you make your reservation. So if you'd like to see the presentations live as opposed to a video feed, which will be coming into all the other locations, then sign up now. So we're looking forward to that. 67 days from now and counting. Okay, one final Mars tidbit here. This was some data from the Mars Reconnaissance Orbiter, one of the spacecraft that's been orbiting Mars and returning all sorts of high-resolution images. And just a couple months ago, it used its high-resolution camera. Well, this is just showing, we know based on lots of our previous observation that the wind is very effective on Mars. These are what we call the shark-toothed dunes. They're about the size of the Great Sand Dunes here in Colorado. And so we see all sorts of evidence that the wind is blowing things around on the surface. Here's a dust devil that MRO saw. This is about 15 kilometers high, so that's 45,000 foot high dust devil. And it's amazing that they just happened to catch it. This is the shadow, so the sun is over in this direction, I guess, casting a shadow. And they made an animation of what this might look like if you were able to see a movie coming back from the spacecraft. Anyway, that was a very cute observation, fairly photogenic. Okay, now let's move on to the nearer home news, and I expect you've been hearing a lot about this in the last week. The first flight of the Dragon spacecraft to the International Space Station. And this is part of NASA's program called COTS, Commercial Orbital Transportation System. And once the shuttle retired, the United States no longer has the capability to carry cargo to the space station, or crew for that matter, but that's a separate issue. So the Russians can launch cargo with their Progress vehicle. The Europeans have what's called the Automated Transfer Vehicle. It's about the size of a school bus. They can carry cargo. The Japanese have a similar cargo vehicle. We don't have a cargo vehicle. And so starting in, I think it was 2006, NASA let contracts to several commercial entities to develop the capabilities to provide resupply to the space station with commercial launch vehicles and commercial spacecraft. And so this is the first one of these to actually launch. So this is by Space Exploration Systems, or Space Exploration Corporation, SpaceX. It was founded by Elon Musk, who was one of the originators of PayPal. If you're familiar with electric cars, he's also in charge of, or owns the Tesla motor company, which sells these electric sports cars. And so they've been working on this concept called Dragon. It's a capsule. It can carry about, I think it's about 14,000 pounds of supplies in the pressurized compartment. And it also has a trunk in the back where it can carry cargo that doesn't need to be pressurized. It's solar powered. And what's unique about this compared to all of the other cargo vehicles, the Russian, the European, and the Japanese, is it can actually return cargo from the space station as well. It's got a heat shield. It enters just like one of the old, say, Apollo capsules. It comes down on parachutes and it's picked up in the Pacific Ocean. So it gives them the capability not only to carry things to the space station, but to bring things back to the Earth, which we've lost that capability without the space shuttle. And just some other pictures to give you an idea of the size here. This is the Dragon being prepared prior to launch with some people playing poker off in the distance. And here's the Falcon 9 rocket, which is also built by SpaceX. This is its third flight. The first one was a test just of the Falcon 9. The second one was in December of 2010, and that was the first test of the Dragon capsule. They just launched it, did a couple of orbits, and brought it back. And this was the third flight. So this launched last Monday, I believe it was, a week ago Monday. And middle of the night, unfortunately, as far as watching it, but it was a very successful launch. And it launched from Cape Canaveral in Florida. And here's a video of that launch. And so this really is a commercial enterprise start to finish. It's subsidized by the government or by NASA, but completely new from the ground up.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And launch of the SpaceX Falcon 9 rocket as NASA turns to the private sector to resupply the International Space Station.
So there are plans to build what's called a Falcon 9 Heavy, which will be tying 3 of these together side by side. So it'll have, the Falcon 9 has 9 engines in the first stage, and so the Falcon 9 Heavy will have 27 separate engines burning simultaneously. I just want to let this go far enough to where you see the first stage drop off, and then there's some really nice video from the second stage showing it looking down on the rocket nozzle on the second stage.
Vehicle has reached maximum aerodynamic pressure. Propulsion is forward nominally, starting stage 2 engine chill. We have fire IR-Flick, power systems are mobile. Vehicles on a nominal trajectory, 30 kilometers altitude, 1 kilometer per second velocity, and downrange distance 20 kilometers. Dragon power systems are nominal. Planned shutdown on engines 1 and 9. First stage, impact point past Mid-Meco.
So there we are looking back down at the, I think actually we're looking up at the second stage, and now we're looking down at the, from the second stage. And this is the rocket nozzle on that motor, which very quickly starts glowing red just from the excess heat from the combustion.
Vehicle remains on a nominal trajectory, 300 kilometers in altitude, velocity of 5 kilometers per second, and downrange distance of 1,000 kilometers. Unused sensor remains healthy, and GPS lock is verified.
Okay, so I'm going to pass on that. It took about 9 minutes to get the Dragon into orbit, and 3 days later it arrived at the ISS. So I think this was on early Friday morning, and this was a view of the space station from the Dragon. It's got infrared cameras and a laser scanner that sort of scans back and forth, and it picks up reflective targets on the space station, and they use the combination of these 2 sensors to tell them how far away they are and how fast they're moving and what direction they need to go to get where they need to be. And so here were some views taken from on board the space station as Dragon pulled up. And you'll notice this object right here, that's a grapple fixture. So this doesn't actually dock itself to the space station. It gets within about 10 meters, and then they reach out with the robotic arm on the station and grab onto this point. And then once it's stabilized, they pull it in and dock it. This is what's called the common berthing mechanism, which is the docking ring that they use. And then they can open a door, and this is all pressurized, so the crew can enter and take the cargo out. And so here we are. There's the station arm attached to the Dragon. And then this was the point that they docked it to. And so this is another video of how this all worked. So here was the Dragon approaching. At this point, I think it was still about 500 meters or so away. No, I think that's just a fly in the video camera. I don't think it's big enough to cast a shadow on the Earth or make an eclipse. And so it's what it does is it pulls up, and then it just becomes absolutely stationary about 10 meters out, and that makes it so that they can just reach out and snag it. And you see how quickly nightfall hits once that happens. And all of these twinkly things here, that's radiation damage to the cameras on board the space station where they get hit by charged particles. It's not actually stars off in the distance. And this is one of the computer displays on board the station. And so they sort of display an outline of where the spacecraft should be, and they can determine if it's behaving properly or not. And so it was actually on the dark side pass on that orbit that they reached out and snagged it. And so this is just an animation of how this actually works once they get it. So it's quite a set of moves on the part of the arm to twist it around and get it oriented to where they can bring it in for docking. This is not human rated yet. SpaceX is hoping to get a contract to actually use this to carry astronauts back and forth to the space station, but that hasn't happened yet. But it's certainly designed with that in mind. And this is the ISS crew then. There's the main door to Dragon. I think this was last Saturday morning when they opened it up. And apparently this is common protocol whenever one of these unmanned craft dock, including the European and the Russian and the Japanese. They're always worried about there being floating debris or contamination of some sort, so they always go in with a breathing mask on and eye goggles just to protect the crew until they determine that everything is ready for them. So I think it's early Friday morning is when it will undock, something around 6 or 7 a.m. our time. So if you are up and have access to NASA TV on the web or on your satellite TV system, then you'll be able to watch this. And so they sort of do the reverse. They use the arm to pull it away from the station and sort of dump it overboard. And then the spacecraft, over the course of the next several hours, will adjust its orbit and separate so that the capsule, the Dragon capsule itself, enters the atmosphere and splashes down in the Pacific. So that's where we are. So far, everything with this mission has gone just spectacularly well. They've had almost no problems, and that's what you would hope for, I guess, for the inaugural mission. And so, assuming that the landing on Friday goes according to plan, then the first actual commercial flight of Dragon could be as early as this September to carry real cargo up. What they did on this mission, they carried about 1,500 pounds of what they call non-essential cargo. There were some fresh fruit and vegetables for the crew, some personal items for them from their families, some clothing, and lots of bags to put other stuff in when the more expanded cargo comes up in the future. And so that's where we are with Dragon. So you can keep an eye out on Friday and watch this mission come to its conclusion. And so there's actually a second company that's part of this COTS program, and that's Orbital Sciences. And they have yet to fly, but they're expecting this fall to have their first mission to the space station. And so they're building their own rocket called the Antares. And unlike SpaceX, they're going to be launching from Wallops Island off the coast of Virginia. And so that'll be a sort of a different location to be doing these orbital missions. And this is their cargo vehicle. It's called Cygnus. And unlike Dragon, it does not have a heat shield. So it's designed just to carry cargo to the space station. And then they can load it up with garbage that they need to get rid of. And once it's on-docked, then it burns up on re-entry. But it's sort of similar to some of the modules on the space station itself. And it's, in fact, the cargo part of this is built by an Italian aerospace agency that built the multi-purpose logistic modules for the space station. So there's a lot of heritage there. And it will behave in many ways like Dragon. It comes in and then stops 10 meters or so away from the station. They reach out with the arm and grab it. And I think we have an animation now of how that'll all happen when it has its first flight later this year. So the plan is once Dragon starts flying, they will do something like 12 flights over the next 5 years. And Cygnus, they're expecting 8 flights over the same time period. So they'll alternate from one to the other to keep the station resupplied. Okay, so that's where we are with the cargo carrying program, and I wanted to end with one other tidbit that's actually happening in our backyard. And somebody asked about how we are going to get crew or transporting people to and from the space station. And so there's a separate program called the Commercial Crew Development Effort, the CC Dev program. And NASA right now is funding 4 different companies to produce commercial spacecraft to carry astronauts to and from the space station. So SpaceX is one of them, where they plan to modify the Dragon to carry a crew of 7. Boeing is building something that looks a lot like an Apollo capsule, and that would have a crew of 7 as well. There's a company called Blue Origins, which is funded by Jeff Bezos, who's the founder of Amazon. And there's not a whole lot known about what they're up to, other than it's another capsule sort of device. And then there's this, which is called Dreamchaser, and it's being built by Sierra Nevada Corporation, which is headquartered up in Louisville, just 20 miles north of here. And so Dreamchaser is the only one that actually looks like a mini space shuttle. It's designed to launch on top of an Atlas V rocket, and then it comes in and glides to a landing on a runway, similar to the space shuttle. But unlike the shuttle, it's really designed just to carry crew and not cargo. It's only, it's probably about 1/4 the size of the space shuttle. And so this is just some views of how this might happen. And then it, interestingly enough, it docks tail end first to the space station. And then when it re-enters, it comes in and lands on the runway. So what's happening now is, I'm sorry, this is an animation of how a mission on Dreamchaser would work. And I don't believe there's any audio on this, so don't worry that you're missing something. How many crew? Potentially 7. There'll be 2 pilots and 5 other crew members. And it has an onboard propulsion system, these 2 larger rockets. It's a really, well, fairly unique system. It's called a hybrid rocket motor. It burns solid rubber, and it uses nitrous oxide, laughing gas, as the oxidizer. And so they can turn the solid motor on and off. They can throttle it. And so that's a very unique capability. And so this would be its landing approach then. So it's actually being built, and this is up at their Louisville facility. You can see it's not all that big, and this is their first test article. They're going to drop this from about 50,000 feet over the California desert and have it do automated landing tests to make sure that it's stable and test the just the capabilities of it. And then they expect to do an orbital test in probably 2014, where they would actually launch it into orbit, bring it back. And at around the same time, they expect to be doing crewed tests where they drop it from the airplane and bring it in for a landing and have a fully human qualified spacecraft. So this is just an image of one of their rocket tests going on. I think they actually lit the motor and turned it off 4 times over the course of a day, just to prove that they could. And this is Tuesday of this week. Jeffco Airport up in Broomfield. They trucked the Dreamchaser down from Louisville, and brought in a very large helicopter. This is what's called a Sikorsky Sky Crane, a cargo helicopter. There's the Dreamchaser. And connected a cable and then carried it off. And this was designed just to be the first, it's called a captive carry test, where they're just checking out the aerodynamics of the vehicle. I think they got up to about 100 miles an hour. They did some banked turns just to make sure that it's stable. And by all accounts, that was a big success. I think we have a real brief video of this. I was wishing, I live in Louisville, so I was wishing I had been driving home that afternoon, Tuesday, at the right time. It would have been quite a sight. I expect it caused a traffic jam on Highway 36. So here's what they'll be doing later in the summer. They're going to use the White Knight II aircraft, which is the carrier for the Spaceship Two, the Richard Branson Virgin Galactic system, where they're going to be selling suborbital flights on Spaceship Two. And so they'll use that as a means to carry Dreamchaser up to altitude and drop it. And so that should be happening late in the summer. So where the CC Dev program is these 4 companies have been developing their different approaches to this and meeting milestones, various design checks with NASA and proving the capabilities. It's expected August, September that NASA will down select to 2 companies. So there'll be 2 companies left that will get much more money to actually carry through to orbital flight tests of their vehicle. And then potentially both of them will provide the crew capability. At the very least, one of them will be given a contract to carry astronauts to and from the space station. And they are thinking that the first flights with crew on board to orbit would be around 2017 if they stick with the current schedule. So there we are. Just to let you know, the next 60 Minutes is going to be on June 27th. And as I mentioned earlier, we'll have Don Hassler, the principal investigator on the radiation experiment, the RAD experiment on Mars Science Laboratory. So thanks for being with us tonight, and hope to see you again next month. So I guess I can try to answer some questions. I can hardly see here. Yes?
What about Orion?
So Orion, I sort of left that out. NASA's program for crew is called the Exploration Vehicle. So Orion is being built by Lockheed Martin, and that will probably have its first crewed flight around 2019. It's a large capsule, it's been called Apollo on steroids. It's being built here in Denver, at least the test vehicles are, by Lockheed Martin. And so that's a separate path from this commercial endeavor. The Orion is not intended to go to and from the space station. It's intended to go beyond low Earth orbit, to the moon, to asteroids, ultimately to Mars. And NASA is building its own new rocket called the Space Launch System, the SLS, which will be a combination of solid rocket motors, similar but larger than what were on the space shuttle. And then to start with, they'll use space shuttle engines on the first stage and sort of do an expanded external tank from the shuttle, and then Orion will sit on top of that. So that's progressing quite nicely as well, but they're sort of 2 separate paths. And I think at a future 60 Minutes in Space, we'll spend a lot of time on Orion, because we've been neglecting that for the last 6 months or so. But they're coming up on some fairly major milestones. I think at the end of next year, they expect to do their first orbital test of Orion using a Delta IV rocket to launch it into a very high looping orbit and then sort of simulate what the velocities would be coming back from deep space, which are much higher than if you're just coming in from Earth orbit. So we'll postpone that for a few months. Yes?
Does NASA know about the Morse code JPL on the wheel?
I'm sure they do by now. And there's not much they can do about it. Yes. I'm sorry, the question was, does NASA know about the Morse code on the wheel? Yes.
Does it have Morse code on every wheel?
I believe so. I think each of so the question was, is the code on each of the wheels? And at least the pictures I've seen, each wheel is identical. Yes.
It's Kim. The Dragon, deorbit, and splashdown is actually tomorrow morning.
Oh, okay. You're right. I'm sorry. My calendar is broken. So tomorrow morning for Dragon, not Friday. Yes.
Is there any sense as to whether or not there is life underneath the polar caps on Mars?
So do we know or think that there's life under the polar caps on Mars? And the answer is maybe. What we're looking for with Curiosity is to look for evidence of habitable environments in the past, that if this crater was indeed a lake, could that have been the type of environment that bacteria in particular could live in? And we know that liquid water is a necessary requirement for life on Earth, and so that's why we're looking for evidence of liquid water on the surface in the past. Right now, the atmosphere is too thin. You cannot have liquid water. It just evaporates. Some people have suggested that under the polar caps, where we know there's big blocks of ice, that perhaps as you get to depth, it gets warmer. Potentially, the water could become liquid, and in which case, maybe things could still be existing in that environment. So we really don't know, and we don't have the capability to look deep under the surface yet. But what we're doing is trying to address what was the climate like in the past when we think it was a lot warmer, had a lot more atmosphere, a lot more favorable to life, and then over time we can start chipping away at these questions. I can hardly see here. There's probably some other questions here.
About how fast do the rovers go, like up between?
So how fast do the rovers drive? And they're about, I think it's about 5 centimeters per second if you have pedal to the metal. So it's about that far per second. So smaller than your hand, probably. The distance record on Mars was set by Opportunity several years ago, and it drove about 140 meters in the course of a day. So a football field and a half in the course of a day. And I think Curiosity is probably not going to go very much faster than that. For one thing, typically you're not trying to set a speed record to go from one point to another. You're trying to get from one rock to another interesting rock, and then you stop and examine that for a week, and then you drive another 15 or 20 meters. The exception to that was when they did this 3-year drive to get from Victoria Crater to Endeavour Crater. And they still stopped and spent weeks at a time in places, but then in between those weeks, they would actually drive for 2 or 3 weeks at a time. So they can cover, over the course of a year, you can cover quite a few kilometers if you really did that every day. But they probably won't. Yes?
Is the International Space Station complete? Are they likely to add more modules?
So is the ISS complete, or is it still under construction? It's termed core complete. It's complete as far as the American side of things goes. The only large piece that's left to go up is a Russian module that's possibly going to be launched in 2014. And it's similar to one of the other modules that's already attached. It's a laboratory module. And that will dock in an automated way, as do all of the Russian pieces to the station. So it's not quite there, but essentially so. Yes.
Why did they choose to use the grappling arm to capture the Dragon capsule rather than automated?
So why did they grapple Dragon as opposed to going in for an automated docking? And I think the answer is it's a lot easier to do. You don't have to worry about the spacecraft colliding with the space station. It's far enough away. You're just coming up at like a centimeter a second in the final approach. And if something goes awry, the crew has time to push the button that sends it away quickly. And it's a built-in capability. It's not. They've done it many, many, many times to grapple things with these arms, and so it's a very known way to do things, and it just makes it a lot easier. Yes?
I have one more question that you didn't really cover this, but one of the recent controversies in planetary science is whether or not Pluto is a planet or a Kuiper belt.
Right.
And if it's a Kuiper belt object, that begs the question as to what is a planet?
So the question is, Pluto got demoted to a dwarf planet, is what it's called, several years ago. And the thinking is that perhaps it's a Kuiper belt object, and the Kuiper belt is this belt of icy objects that are well beyond Pluto. What is a planet is really purely semantic. And I think lots of people get very heated on the argument about Pluto, of how the definition was come up with. In reality, things like that aren't a democratic process where you just vote and the majority wins. It was sort of a group of people that sort of forced this on the rest of the world. So that's probably what sticks in a lot of people's craw. But that's one of the reasons why they had that debate, is we started finding more and more objects that were Pluto-sized, and then we found one that was actually larger than Pluto. And so the thinking is, in the not-too-distant future, as our technology to observe these small bodies gets better, we're going to have thousands of planets in the solar system, and so we probably need to come up with just a definition that keeps the host of planets to be relatively small, and then we have other categories for all of these other objects. But I'm sure Pluto doesn't care what you call it. And by the way, we're rapidly approaching the New Horizons flyby of Pluto. That'll be in mid-2015. It's not that far away now, so something else to look forward to once Curiosity leaves the headlines. Yes? So how did Mount Sharp get there? And that's a really good question, because it appears, since it's all these layered rocks, that it was laid down after the crater was formed. And we see that in other places of Mars, where it looks like these surfaces were deeply buried in other sediments, and then things got eroded away subsequently, and you leave debris behind, like Mount Sharp. So that's part of the mystery. You'd be talking about tens of thousands of cubic kilometers of material being broken down and blown away probably by the wind. We don't know. And that's one of the things they're hoping to find out then, is, was this whole thing just under an ocean, where perhaps the crater was on an ocean bed and things started building up, and then once the ocean went away, you had this left behind. But we'll have a lot better idea in this time next year, hopefully. Yes?
That sky crane system seems pretty complex. Did they build a duplicate to test it?
So the sky crane on Curiosity, they've tested the parts. All of the parts have been tested, but you cannot test the whole thing on the Earth because it's under Earth gravity, not Mars gravity, so you can't scale it up or whatever and make a realistic test out of it. So they've done the best they can, which is you verify each of the individual pieces, each of the individual systems, and then you simulate how they all talk to each other and work. So They claim that they've tested this to the high 90% likelihood of success, which is, I expect, the best you could possibly hope for. And ultimately, it, to some extent, comes down to luck. If there's a rock, the size of 6 of these chairs that it comes down right on top of, it's going to be a bad day no matter how well they've tested it. So we've been very lucky on many of our missions, like Spirit and Opportunity and Phoenix and the Pathfinder mission, but we've been very unlucky on other missions. So it's one of the reasons why we have these nail-biting events like we will on August 5th, is to try and have everybody here watching, and we'll all find out together. Yes?
Is there any possibility that Curiosity could get stuck in the clay?
So could Curiosity get stuck in the clay? And it's possible. That's sort of what happened to Spirit. It drove into a small crater that was filled with very fine material. But the wheels, the drive system on Curiosity is much better, much bigger than Spirit. And the spacecraft itself weighs about 5 times more than Spirit and Opportunity. So all of that combined gives it, I think, a lot more traction. They claim that they can actually climb over things that are at least twice as high as the wheels, although they probably won't, but the capability is there. So I think it has a lot more capability, and plus it's nuclear powered. It doesn't have to worry about getting in an inopportune position relative to the sun, which is what happened to Spirit. It was pointed away from the sun, and eventually it just, the batteries died, and that was that. So, but I think they know a lot more what to look for as well, as far as sand traps and things that might be dangerous, and they'll certainly spend a lot of time just trying to figure out the landscape and being safe. Yes?
Is the Dragon capsule, is that reusable, or is it just a one-shot?
So is the Dragon capsule reusable? Yes, it is. And I don't know what how frequently they'd be able to use them or how long it takes to refurbish. I think they end up changing the heat shield, and that's probably the primary thing that has to be changed out, because that actually ablates, it melts and flakes off when it's entering.
On that patch for the one ship that was Shamrock, is there a significance to that?
Okay. Say that again.
On the patch for, now I can't remember which one it was, there was a Shamrock on the bottom on the Dragon.
Oh, okay.
Is there significance to it?
I assume the shamrock is for good luck.
Well, and the stars that were there, it was like they were mirror images for 3 sets. Were they supposed to be a particular?
I don't know the answer to that. I'll try to find out for next time. Yes.
You had mentioned Jeff Bezos and the PayPal guy, and I'm
Right.
familiar with Peter Giamatti. Is space entrepreneurship something that's more of a flourishing industry now after budget cuts, or has it always been? You know?
Well, so the question is space entrepreneurism alive and growing, and has it been around for a long time? I think the answer is things like SpaceX. They actually founded that back, I think it was around 2001, 2002, and they worked for a number of years to try and develop their first rockets to carry spacecraft commercially into space, as opposed to using Lockheed or United Launch Alliance or Boeing. I heard an interview with Elon Musk, the head of SpaceX, about a week ago, and the problem with the whole space commerce, if you will, is it is going to take a long time to turn a profit. And so it's a very expensive thing to start up. They've already spent about $1 billion of Musk's money on SpaceX just getting to this point, and their main customer to start with is going to be NASA, and they're going to get something like $1.6 billion over the next 5 years. That's some profit margin built into that, but it's not like Apple stock, going through the roof as it has been lately. So investors typically are very wary of pumping large amounts of money into these things because the payoff is going to be much farther down the road than the standard investment. And so that's, in the same interview, the people writing this said that's where people like Elon Musk and Jeff Bezos come in, that they're already billionaires, they have a passion to do this, and they're willing to expend their own funds to get to a certain point. And then if at that point it's profitable, then potentially it can and will take off. But it's likely going to take a while. But I think we've gotten to the point where technology is such that if you have $1 billion and you want to do this, you have some reasonable likelihood that you're going to be able to get something off the ground. Unlike if you had have tried this 20 years ago, I think the answer would be that wouldn't have been very likely. So we'll see. I think that's where this is all heading. The push from the current administration and NASA is we need to commercialize at least low Earth orbit and make it much, much cheaper to get payloads into orbit. And then, you know, NASA will do the deep space exploration side of that, and then eventually the commercial side will follow. Elon Musk claims that once Dragon starts flying, that will be qualified to take cargo and crews to the moon and eventually to Mars. And he's predicting within 20 years they'll have these things landing on Mars. So we'll see. Okay, thank you. And we'll see you next month.